Myself Kotha Roy. Today I'll be presenting on the topic Introduction to Database Management System. So in this presentation we'll be basically dealing with the very basic of DBMS, which has been taught to us as our curriculum. I mean, till now what has been taught to us. So just a moment everyone. It's TH. Honest mistake, you see. So yeah, I'll be doing this presentation as the part of our course MCH61. So here my presentation goes. Firstly, we'll be talking about the first objective of our this presentation, that is to be clear about the fundamentals of database management system and improve ourselves. So the fundamentals, that is the basic of the DBMS, will be enlightened on the fundamentals and basic of DBMS in today's this presentation. So let us proceed to the introduction part. Well, DBMS. The word DBMS stands for Database Management System. So what is database? If we take the very literal meaning of the word database, so database is generally a collection of data. Well, if we take an example, mm, let us take an example of a school. Suppose in a school, a class has 100 students. So the register where the roll numbers of this 100 students would be stored would be known as the database. And those 100 tickets or entries would be known as the data. So from this we can see that database is generally a collection of the data. That's it. And the meaning of the word base, well, base or anchor for anything means the very starting or the collective point. For example, if we take the instance of soldiers, because the word base camp is directly been used. Suppose a group of soldiers has been posted in Kashmir. So the Kashmir base camp have certain number of soldiers, and those soldiers would be the names of those soldiers would be the data for the base camp of Kashmir. So that is the relation between data and base, hence the term database. And if we break up this management system thing, well, the management system things are very much literally used in this term, because what we understand from the term management is managing, organizing, or to see that if a thing is going on perfectly or not. So that is the term management. And a system, well, anything including a user and an installer is known as system. So that is what a database management system is literally. Now the second point, DBMS is a software system for creating, organizing, and managing the database. So yeah, of course, if a database has been created, like the school's database, so of course we can't just sit idly after creating a database. Once a database is being created, it needs to be kept organized, or it needs to be kept updating. So I mean, updation is needed every time. So yeah, DBMS is a software system for creating, organizing, and managing the database. Well, the third point, it provides an environment to the user to perform operations on the database for creation, insertion, deletion, updating, and retrieval of data. Well, if a database is created, let us take the example of the school's database one. Well, a database is never a static thing, right? If we take the example of the school's database itself, It might happen that a student want to take admission on some special criteria in midterm. So in that case, we can't deny the student on the deny the admission of the student on the fact that no, our database is a static database, we can't update it or insert your kid's name. That is not possible, right? So a database is always a dynamic thing, which means it is under constant change. It might happen that a student similarly wants to take admission in midterm, might also want to leave the school in middle of the year. So in that case, deletion is needed. In case of admission, insertion is needed, and updating and retrieval of data. Updating and retrieval, these two are such things that when anything involves creation and deletion, these two things automatically comes up, because if we insert a data, if we insert something, the updation happens. If we delete something, the updation it takes place. And retrieval, of course, if a bunch of records are there in a database or in any place, um, it needs to be retrieved. I mean, we don't store records just to look at it at leisure time, right? We need to use it at the time of need. So yeah, these two are quite obvious things which comes up with the creation of database. Now we'll move to the basics of data, right? So what is data? I have already explained it. So let's see, a collection of raw facts and figures, of course. So for example, in that school which we were talking about, suppose a student named Ramesh is being admitted. Okay, so Ramesh, the student comes up with several raw facts and figures. I mean, anything, any entity, any object, any living or non living thing comes up with certain facts and figures. Nothing is made up about a thing, right? Else it wouldn't be an fact. So, in case of Ramesh or a student, what would be the raw facts and figures? Well, his parents' name, his maybe registration number, he has a particular date of admission, his date of birth. This certain thing would be data of Ramesh. Now, if we consider the big picture, that is the database, so what would be data for this database? It would, of course, be the name of the students or the roll numbers of the students. Those are the main, very primitive data for the database. Okay. So the second point is raw material that can be processed by any computing machine. Well, raw materials. So for Ramesh or a particular student name, the facts or the other related datas related to the student name thing is being processed using different things can be processed. For example, the most widely used thing that we use worldwide is Excel sheet. Excel sheet are something that are used to store data because it's very user friendly, and yeah, that's not our concern still. So we can't just randomizely store the data anywhere we want. We need a place to store. So Excel sheet is such an example. Others are Oracle database, many other examples are there. So that is the tool which is used for computing these facts. Now the third point, a collection of facts from which conclusions may be drawn. So of course, data is a collection of facts from which conclusions may be drawn. So as I was saying, the student's name, if it is inserted in a database, the conclusion that we can draw from there is that this particular students, the 100 students belong to this or that class. It will depend on the name of the register. That's what this point means. Well, the fourth point, data can be represented in the form of numbers and words which can be stored in a computer's language. That is, here example is given Pansing or Anshul 007. Well, of course, a data can be represented in any form. For example, we generally write our first name first, then comes our last name or surname. But we have seen many a times in our report cards or in boarding pass of airports, generally our surname comes first, then comes our name. So in those places also our names are stored in a database. But the format of our name changes, or it's a bit different than usual. Well, that doesn't mean that it's an illegit database, right? It just means that the format in which our data are stored in a database entirely depends on the user, the first end user. Okay, it there is no mandate or particular protocol regarding this format of storing the data in a database, right? So next we'll be seeing what is information. Now we know what is data, but data's what are data's used for? Well, data's are of course used to retrieve an information or conclude an information. The end product of certain data would be an information. So the very first one, systematic and meaningful form of data. Of course, any randomized data would not make up an information. Okay. For example, I'll be giving two examples over here. So first one, let us consider this very first sentence, systematic and meaningful form of data. Well, here if we consider each word to be data for this sentence, so what I want to say is, to be more precise, let us consider this sentence to be the database and this single words to be the data of this database. So if so over here, if I just put the words in a very randomized way, like data, meaningful, of, form and systematic, so is it making any sense? Well, of course it isn't making any sense, because it isn't in a systematic way. It's in an ambiguous way. A set of words is just given, but we can't make out that what information is this word giving. Likewise, if we take the technical example of the student database, in the student database we can't just put some random words as information. Okay. For example, if we consider that same example of Ramesh, so just imagine that in the database for Ramesh, for the entry Ramesh, certain words are given, just random words. Mm, Suppose Mrs. Suri, Mr. Suri, 78, 8 by G by 1. So, can we make out what this thing means? Well, of course not, because they aren't in a systematic way. But if the first end user mentions a particular proform or a protocol for this saving, which can be like the first end user can, at the very first of the execution, can make aware the last end I mean the end users about the format, like, see, look, for a particular entry of a student, the first entry should be the student's name, the second must be his mother's name, the third for his father's name, the third fourth would be for his maybe registration number and house number respectively. That can be and we Another way can be that for each entry there can be different, you know, blanks or columns, which we'll be discussing later. That can be done. So a system, a basic system is required for meaningful information to conclude. Second point, knowledge acquired through study or experience. Well, of course, information can be said as the knowledge which is acquired through study or experience. Information can't be made up. To give an information, you have to understand that it's a real thing. I mean, if I say that APJ Abdul Kalam was once the president of India, it's an information because you can check this, verify this if you want. You can, you may or may not have experienced this, but you can experience the verification. You can acquire this knowledge. But if I say that I think she's a girl or she might be a girl, might or maybe part is coming up. This is just a random thing which I'm telling without any verification. I'm just saying it on the basis of my doubt. So that cannot be said be that's an incomplete information. I won't say it's isn't an information. Of course it's information because it makes sense, but it isn't it's incomplete, right? Third part is benefit of information, that is information helps human beings in their decision making. Well, of course, if you have clear cut information with you before making any, before proceeding with anything, of course it will help you in a clear decision making. For example, in mutual funds. Now, database, yeah. So what is database? A repository of logically related and similar data. Well, a repository means a place or a place to store anything, or it's just imagine of a warehouse where things are stored. Well, it would be what we is a local term. What we can say, a repository in local term, you can say it as a junkyard or anything. In a, like in a junkyard you store junks only. So repository is a place or a place for a particular things to be stored. Yeah, so repository of data or would be known as database. Repository of logically related and similar data. Yeah, so logically related and similar, these two are quite important in the making of a database because um, let us take an example of a school. Suppose St. Augustine's Day School. So St. Augustine Day Schools, let us say, that maintains a register with the name of all its students. Well, would it make sense if the register contained the information of the school students itself plus some others? Let it be Douglas. So St. Augustine is a school which maintains a register of containing names of both the students of their school as well as Douglas's students. So does it make sense? Well, of course not, because now this is not a database. It has just become a concussion of datas, a confluence of datas. Just some random datas have been put inside it. This is not taking a part of information. The end user can't get a particular information. When someone sees the database, several questions will be raised in mind, like why there's a mixture of students of two school in a particular register while they are not related, right? So a database is usually made of made for a particular thing. I mean, it's a mixture of entities, but it is related to a particular thing. For example, in a superstore, suppose invoice database is made. So an invoice database would only have the invoice generated for each customer. That database won't have any other thing like MRP of things which are found in some other store or the customer's address or anything. No. A invoice database would only have the invoice generated for each customer because those are similar, and you're also getting logically related. So whenever the term database comes, the terms logically related and similar data comes hand in hand. Okay, now a definition for database: an organized collection of related information so that it can be easily accessed, managed and updated. Well, yeah, of course we have discussed this point earlier. Now, for example, dictionary, airline database, student database, library, railways, timetable, YouTube, all songs of Rahul Vaidya in brackets. So, the last example is quite an important one in terms of understanding, because from here we can understand that again, YouTube has several playlists, okay, which means we can imagine YouTube as a junction or a repository of several other databases. Okay, all songs of Rahul Vaidya would make a database. All songs by Coldplay would make a database. Again, all songs by Carpenters would make another database. If we have a database or so-called list of songs by all the singers, it just becomes a mixture of data. It's not a database. So yeah, now I'll be moving to data model, schema and instances. So data models are nothing, they describe the structure of the database. Okay, so when a third party sees the, before seeing the database, I mean before going into the depth of the database, they need a basic idea about the database, like why the database exists, what is it doing, what type of records does it store. So for understanding those type of things, data models are a necessary part. The aim is to support the development of information systems by providing the definition and format of data. If the same data structures are used to store and access data, then different application can share data. If the same data structures are used to store and access data, then different applications can share data. For example, if same data structures, like, I'm sorry, if same data structures, for example, For example, let us consider a stack, because the records are stored as in a stack form. Well, not a stack, just this is just for clarification, okay? Don't consider it literal. Suppose the data are stored in the form of stack. Now, if we want to access the data over there, I mean, different applications. We all know that database, a particular database, can be accessed by several other applications, okay? I mean, the database is shareable, okay, that is the fact. The data of the database are intershareable. So if the data structure part, suppose table A is in a stack ways, in a stack format, table B is in a queue format, if they are in separate other formats it becomes a bit difficult. But if they are in the same format of data structure wise, then it's easier. That's it. Now the classification. Well, there are three types of data models: high level model, representation model, and low level model. So let's see. Ah, High level model ensures data requirement of the users, not concerned with representation, but it must be conceptual. Yeah, that's a major thing for high level model, that the concept part is necessary and it ensures that the data requirement of the users is made. Three important terms: entity, attribute, relationship. Okay, so entity, anything can is in this world present, living or non-living, is known as entity. Any object exists physically or conceptually. For example, a cell phone or a laptop is something that exists physically, is an object which we can touch and see with our hand. So that's an entity. And in terms of concept, if we speak, well, latitude, longitudes, we know them, but they are some imaginary lines which we made to for our ease, right? They are conceptual, but they doesn't exist in reality, but still they are an entity. Well, attribute, property or characteristic of entity. Well, of course, an entity might be living or non-living, real or virtual or non-real, but everything has an attribute. For example, latitude and longitude are straight lines. They have certain degrees. They are used for finding out, to ease the problem of time gaps and date lagging across the continents and countries. But these are latitude and longitudes are totally conceptual, imaginary things, but still these are these entities, right? Same for laptops and cell phones. Laptops and cell phones are something real which we can touch and see with our eyes. They too have some attributes, like laptop has a square rectangular shaped monitor, a cell phone is portable, laptop is portable as well. uh, Laptop has more memory than cell phone. So yeah, that's what attributes are, be it real or non-real, everything has attribute. Relationship, association or link between two entities. Yeah, I'm sorry. Two This thing again has been mentioned earlier, that every entity must have relationship between them. For example, in a database, similar entities must form records. Okay, it can't be possible that in a database containing breeds of dog, suddenly some cats have been inserted. It will not make any sense. So these three terms make entity relationship model. Here is an example. These are two separate example actually. See, here college has a principal, college has student A, B, C. To the second example, college 1, 2, 3, course A, B, C. Again here in this second example, well, if this three college is different, this three courses are different as well, but still these are in the same database or ER model, because this courses and colleges are interrelated among themselves. Like college 1 has certain courses which college 3 as well has, college 2 has certain courses which both college 1 and 3 has. So this is a relationship is there, a common factor is there, to be precise. Well, this is an diagram, a ER diagram. So yeah, now let's move on to representation model. Representation of data stored inside a database describes the physical structure of the database. Well, of course, if a thing is made, it has a physical structure, right? Physical structure means the way the records are being stored, or the technicality of the database. It uses the concepts which are close to the end user. The end user means the final users. I mean, not the installer, but the users who would be using it on the long run. Well, it has classification, hierarchical, relational, and network. Okay, we would be more importantly enlightening on the relational database model, because relational database model, as it is mentioned here, simplest and most common model. It is the model which is used worldwide nowadays because it's easy to understand. It doesn't have any complication. It's just, it's an ease to your eyes. That's why relational database model is widely used. Some extra information, like developed in 1970 by EF Pott, and it became commercial in the 80s. Well, data elements are stored in different tables made up of rows and columns. Data values. the terminologies are really important in any case, in whatever thing you do. Terminologies are something that are related to even a normal CD, a DVD drive has some terminologies which is necessary to understand them well. The terminologies for this relational data model: data values, alphanumeric raw data. This has been explained with this instance. Okay, so here alphanumeric raw data, for example, Rajkumar. Alphanumeric raw data. Alphanumeric means data type which contains both alphabets and numbers. So here the name is given as Rajkumar, but we could have saved it as Rajkumar 11, 12, 2.0, something like that. Yeah, okay. So columns and rows. Well, columns and rows have their regular meanings in this table as well, but the extra special thing about them is columns generally contain the fields, or fields in the sense they contain the headings under which the records would be saved. Okay, and rows are the particular record or entries. Table, well, the collection of the several rows, columns, and data values, or these records, is of course the table. Key is the identifier. Well, keys are generally of primary key, local key, and foreign key. There are three types of keys. Well, keys are, let's say, like in those who have given ICSC or IS exams, you have a unique ID in along with your roll number, right? Those unique ID as are totally unique to you. I mean, no one else has this thing. So keys are something like that. A single record will have a particular key which is very much unique to that particular record. Okay. So here are some example where this type of tables can be created: Oracle, SQL Server, DB2. Now we will go to, just a second. Huh. Now we would go to client server architecture. What is a client server architecture? So as I have said earlier that, huh, just a moment please. Uh, okay, let me place it over here. Okay, all right. I hope it's visible properly now. Hmm. So a database has a client server architecture. Okay. So what does a client and the server mean, right? In cases like this, generally the end user or the one who will be using these whole software or a DBMS, or the final product would be the client. Okay, and servers are generally machines or the sources using which, I mean, it acts as a tool for the client to access. Now, of course, DBMS has a basic centralized DBMS structure as well. So this is the traditional form. See, in the traditional form, the enterprise, here it is shown as enterprise database, that is the main database. One to all type of service is there. Okay, and for this client server, one to one type of relation is there. So involves a client and a server, of course. Clients are PC or workstation, that is the end user. Servers are powerful computer, can manage files, printers, and emails. Client interacts server when additional functionality doesn't exist in its own machine. Here is the diagram: user interface, application program, database, tables. See, the user accesses the application program and the records entered in the application program is stored in database tables. It's a two-way path. Okay, so if the user want to retrieve it, then the user simply accesses the application program, retrieves the necessary details from the database tables, and the user gets it. So now we'll be focusing on some advantages of a DBMS. Controlling data redundancy, data consistency, control over concurrency, backup and recovery procedures, and data independence. Well, of course, the data which is being entered are independent of each other. They are similar, but they are independent. They're unique. Okay. Backup and recovery procedures. Of course, when you are saving a certain data or certain number of records, a backup is created. Okay. So why a backup is necessary? Because the data which you require can be recovered multiple times, any number of times from a backup. Control over concurrency. Okay. So you can overwrite a data in DBMS. If you want, you can insert data in a DBMS. You can delete some other data from the DBMS. There's all three things are concurrent to each other but are not related to each other. It's not like that if you delete a particular data, some other data gets overwrites or overwritten. Okay, that is the thing. Data consistency. Well, of course, the order in which we will save the data, the protocol which will set for the order of the arrangement of the data would be consistent throughout the database. Controlling data redundancy. When you enter the data or the record is not lost or duplicated or moved to some other place unless you do it. If you enter something in a particular storage place in a database, it stays there until you manipulate it. Now comes examples of DBMS. What are the examples of DBMS? Some of the common used DBMS are Oracle, IBM's DB2, Microsoft's SQL Server, MX Access, and Informix. Some of the desktop-based DBMSs are Microsoft Fox Pro, Borland DBase, and Microsoft Access, and also Excel Sheet even. Okay. The difference between these two types are desktop-based DBMs are more user-friendly. Okay, but this common use DBMs, mm, they are in more of a raw type of thing. These are user friendly too, but they lack the interface which generally user friendly stuffs have. Okay, it's more of a raw, very preliminary type, but they are easy to use once you know it. It's not tough at all. Now we'll come to the very basic of the creation of DBMS. Well, when you write the term, first let us consider that this table's name is book. We are creating a table named book. Fine. So we will write create table book. Let me change the font color, if you will. Black maybe. Create table book. So a table then gets created. After that, these records need to be inserted. How do we insert? We write insert values. Well, let me say one thing. It's very important that this is an example for a typical Oracle database. Okay, it's a typical example of Oracle database. Oracle SQL Server. Yeah, so suppose create table book, a table which is named book. And yeah, the thing I was talking about earlier, that in this Oracle SQL Server, it's not case sensitive. Okay, it's not at all case sensitive. The insert can be written in small letters as well. Values can be written in capital or small letters, whichever way you want. So if I write insert values, then you have to insert the value. Suppose here Kyle's mom is the first one. So then others are Let us consider other values are also inserted. Okay. So after the insertion is done, the rows are being created. We want to retrieve some particular row or record. Okay. So over there we can use the term select name. Here what we are doing is we are retrieving the column, only the column name from this whole table. Okay. Select name from book where publisher equals to chef. So a condition is being added that from the name, a particular row has to be retrieved where the publisher's name is chef. I mean, if this condition wasn't given to this command, then this second record would have been come out as the output 2. Okay, but since this condition is given, only the first row, this first row would only be returned as the output. Okay. So now we would see some wildcard characters in SQL Server. Well, wildcards are literal wildcards over here, okay? Like a wildcard, a trump card, or a hotkey is used for momentous help, or they just give instant helps to us, okay? So wildcards also do the same thing. So here we can see this ampersand, hyphen, underscore, upper arrow, square brackets. These are certain wildcards over here. For example, ampersand represents zero or more characters. Underscore a score represents a single character. Brackets represent any single character within the brackets. Upper arrow represents any character not in the brackets, and a hyphen represents a range of characters. Okay. Now, all the wildcards can be used in combinations also, for sure. Here are some examples of like operator with ampersand and a hyphen. So yeah, select where like these are operators, okay, and the symbols are the wildcards. So yeah, let's take, there are several examples, you can look through them. Well, let us take consider this example where customer name like a ampersand, okay. So over here, suppose a table there is suppose there is a table, there is a column named customer name like a ampersand, means it finds out any value in the column customer name which starts with a. Okay, these are similar type of examples. So from this we can understand how this wildcards are used with combination with the operators. Now this is just a small, very small thing which I wanted to insert in middle so that it's being highlighted that what a DBMS is actually doing. After going through all the stuff, so we can understand that a DBMS is actually doing nothing but it's a two-way path. The user is giving certain inputs, they are stored in the database. When the user needs, it can simply retrieve those records from the database. So database is just like a backup. DBMS is the software using which the user gets the record. Okay. Now these are certain examples of the commands that has been used earlier. See here, the table cust has been created earlier, and we are using the Scott username with the password tiger. Passwords are never shown. And I am using a 11G version of SQL Server. Well, the latest is an 11G. Some other, I guess, S or version, something else is there. Okay. So here the customer cust table was formed earlier. Now we want the DSC, that is the description, like what are the data types, what are the rows that have columns have been inserted. Okay, like this you see. Now if we write select star from cust, which star here mentions all, okay, so if we write select star from cust, it shows all the entries, all the records that have been inserted in cust. Okay, the second example is this one. Here there is a exception. Here we are using the wildcard. Select last name column from cust table where L name like contains contains values which ends with s. So it's retrieving the values from last name column of the cust table which only has s as last letter. That's eros. Okay, over here. And the second place, I'm sorry. And the second example, we are seeing that we are finding out all the columns of the all not all the columns, the area column from the table cast, where all the values of the area has the end value as a. Okay, such examples are shown. Lastly, we'll be seeing of applications of DBMS. Well, we know that it's widely used in schools, as I have mentioned earlier. Some other places are airlines and railways, banking, education, telecommunication, e-commerce, human resources, and hospitals too. I mean, any place where there is a customer, no, customer seller relationship, or installer user relationship, in those places DBMSs are of course used. So here I end my presentation. Thank you everyone for seeing my presentation, attending it. Thank you very much.